All right, topic B is on trigonometric ratios, which is really the foundation of what you guys need to know for today's topic, for today's lesson. So the first thing that we need to do is we need to look at what we have written here and answer these questions. So first of all, you need to make sure you know what the hypotenuse is, which we discussed in the last video. It's the longest side of the right triangle. It's also the side across from the right angle. The hypotenuse will always be the hypotenuse no matter what. But there are some sides that we will look at as well that are considered adjacent and opposite. And those can change, but again, the hypotenuse will always stay the same. So if you look at the word adjacent, hopefully you know that adjacent means next to. So we're going to find the length of the side that is adjacent to angle A. So here we've got angle A right here, okay? So we're going to be taking a look at this angle right here, and I'm going to look for this side that's adjacent to it. Now there are two sides that are next to angle A. There's this side length of 5 and the side length of 4, but remember the side length of 5 is the hypotenuse and it will just stay the hypotenuse. We won't consider it the adjacent at all. So that means that the side that is adjacent to angle A is this 4, or side length AB. Okay, so we'll say that AB is the answer to this first question right here. So what is the side that is opposite angle A? Let's answer this question right here. So the side that's opposite angle A is the side that's going to be across from angle A. It's not touching angle A, which is this side right here, which is length BC. So the answer to the question for the side that's opposite angle A is side BC. And then let's go to the last question, the hypotenuse. Remember we said will always stay the same, so hopefully you know that the hypotenuse will be side AC. Okay? Based on that, I want you to see if you can figure out what the side is that's going to be opposite angle C and adjacent to angle C. So go ahead and try that. Press pause, answer the question, and then come back to me. You got that the side that's opposite angle C, the one that's across from this angle right here, is side AB because it's right across from it, okay? And hopefully you got that the side that is adjacent to angle C is side BC because it's the side that's next to it. Now one thing that you need to make sure that you do, and I forgot to do this with you, is we need to put little line segments on top of each side length to indicate that they are line segments, okay? Now, what is trigonometry? Trigonometry is the branch of mathematics that deals with the relationships between the sides and the angles of triangles and the calculations based on them. Now, here's the thing that's really important for you to understand. Basically, it has to do with ratios. All right triangles that have the same angle measurements are proportional to each other. So, for example, if you are given a triangle right here that looks like this, and I tell you this is a 3, 4, 5 triangle, and then I give you another triangle, and let's say this is a right triangle, and then I give you another triangle, and I tell you that the other triangle right here has a side length of 6 here and a hypotenuse of 10, you can automatically conclude that this length right here is going to be 8 because the two triangles are proportional to each other, okay? It's just kind of like what we did when we talked about dilations. It's the same triangle, but it's just dilated with a scale factor of 2. Basically, what trigonometry says, again, is that all right triangles that have the same angle measurements, so this angle right here, will always be equal to this angle right here if the two triangles are proportional. Okay, so all right triangles with the same angle measurements will always be proportional to each other. All right, so I'm going to show you guys something so that you can kind of understand this concept a little bit better. So if you look at this right triangle, we know it's a right triangle because it says that the measure of angle ACB, so if you look at it and you follow angle ACB, which means that this angle right here is 90 degrees, and it also tells you that the measure of angle CAB, which is this angle right here, is 22.4 degrees. So we know it's a right triangle because it has a 90-degree angle in it. Now, if you notice, this angle right here is what we're going to be really looking at. So we're looking at right here, angle A, basically. All right. So angle A right here is the angle that we're going to look at. And if you look at side CB right here, this is the opposite side to angle A. All right, and side AC is the adjacent side to angle A, and side AB is the hypotenuse. Don't worry about the slope. That's not something we're going to be really talking about right now. Now, if I show you the ratios of the triangles, or of the sides of the triangle, if I take the opposite, which is side CB right here, and I divide it by side AC right here, so if I take the opposite and divide it by the adjacent, I get 0.41. So I get some type of number, okay? Now, watch what happens when I change the length of side CB or side AC. Okay, so if you look right here, they're going to change sizes, hopefully. So look right here, the sizes are changing, but notice the ratios are staying exactly the same. And this is what I was trying to tell you before. It does not matter how big your triangle is, as long as the angle stays the same, the ratio will always be the same. Okay, no matter if the ratio of the sides, so right here again, the sides here were CB to AC, so is the opposite over the adjacent. We have CB to AB, so we've got the opposite over the hypotenuse. And then over here we've got AC to AB, so we've got the adjacent over the hypotenuse. This is all relative to angle A. So the nice thing about this, about trigonometry, is if I know what the size of the angle is, I can use it to help me predict how big the sides of the triangle are going to be. Or vice versa, if I know how big the sides of the triangle are going to be, I can use it to predict what the angle is. So again, if you notice, the ratio never changes no matter what. No matter how big the triangle is, I still have the exact same ratio. Now, these special trigonometric ratios have special names, and those names are going to be sine, cosine, and tangent. Now, we write down SIN as an abbreviation for sine. Please don't call it sin because it's sine. Please don't call it cos because it's cosine. Please don't call it tan because it's tangent, okay? So we've got sine of an angle, cosine of an angle, and tangent of an angle. Now, one thing I want you to understand is that this is function notation, which you should be familiar with from the algebra, in the Algebra Common Core class. So it's not sine times x, it's sine of some particular angle, okay? So the sine of any angle in a right triangle will always be the opposite over the hypotenuse. And press pause if you need to, if I'm going too fast for you, but these ratios are super critical. You got to make sure you get these down, okay? And then the cosine of an angle will always be the adjacent over the hypotenuse, and then the tangent of an angle will always be the opposite over the adjacent, okay? Now, a lot of times you will see me writing it out as follows. So I'll write it out as sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. And sometimes we call this right here SOHCAHTOA because it just kind of spells out SOHCAHTOA. All right. And then there's a few mnemonic devices that you can use to help you remember sine, cosine, and tangent. The most common one you'll hear is some old horse caught another horse taking oats away. You can use whatever you want. Now, if we revisit this picture that we were looking at earlier, remember the ratios aren't changing at all, even though the side lengths are. And we have, again, this is based on angle A right here, so this angle right here. We have CB, which is the opposite of angle A, over AC, which is the adjacent. So if you have O over A, if you look back right here, opposite over adjacent is tangent. So this is basically the tangent of the angle. So if you look at this right here, the tangent of angle CAB is 0.91, which is the opposite over the adjacent. Here, CB is the opposite over AB, which is the hypotenuse, and if you look back, opposite over hypotenuse is sine, so the sine of the angle is 0.67. And then lastly, you've got AC, which is the adjacent, over AB, which is the hypotenuse, which is opposite, or sorry, adjacent over hypotenuse, which is cosine. If you look back here, it's cosine, which is 0.74. And it never changes. It always stays the same right here, okay? This right here, the angle measurement in this case was 42.3 degrees. It's different than before because every time I open it up it just does a random angle. But just so that you know, this time it's 42.3 degrees. And if you type into your calculator the tangent of 42.3 degrees, you'll see that it will pop it out as 0.91. So how do you do that? What you need to do, and I apologize in advance, I will be showing you more work on how to use the calculators with the trigonometric ratios in class. Because I can't really show you because I don't have the software right now, but I will show you what you need to do just to keep us going for now until tomorrow when I see you in class. So there's two ways to type in sine, cosine, and tangent. You can literally type in the letters. So on the bottom, you're literally just going to type in TAN, and that's it. Open up your parentheses, and remember the angle measurement was 42.3 degrees. So what you're going to do is you're going to type in tangent, open parentheses, 42.3, close your parentheses, and then press enter, and you'll see 0.9099299888178. Depending on how far out your digits go, it might be less than that. But that's basically 0.91. Okay, that's one way to do it. Another way to do it is if you see underneath this control button, you have an equal sign. To the right of it, there's a trig button, and if you press the trig button, you will see sine, cosine, tangent, and then 3 other trigonometric ratios, which you won't learn for a while. And then underneath it, you'll see something that says sine to the -1, which means inverse sine, which we will talk about in a couple of videos. Inverse cosine, inverse tangent, and then the other 3 trigonometric ratios again. So basically, that's really what it means to take the sine, cosine, or tangent of any angle in a triangle. All right, so let's put this into practice a little bit. I'm going to write out our little mnemonic device, or sorry, our symbols that we use just so that we can remember which one is which. So remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so in this question, it's asking us to figure out the sine of angle x. Now, if you look at it, here is angle x. Sine is going to be opposite over hypotenuse. Now, the hypotenuse will always be 41 because it's across from the right angle. And the side that's opposite angle x is 40. So this means that the ratio would be 40 over 41. Okay, because this is the opposite over the hypotenuse. All right, now cosine is the adjacent over the hypotenuse. So cosine of x, remember this is based on angle x right now, the adjacent side to angle x is 9. Okay, and then the hypotenuse is still 41. So the cosine of x would be 9 over 41. Okay, and then lastly we have the tangent of x, which is the opposite over the adjacent, and the opposite over the adjacent will always be 40 over 9. Okay, so here we've got 40 over 9. I want you to try the same thing with angle z right here, but instead of doing this problem with me, I'm going to have you press pause, try it, see if you get the 3 answers right, and then come back and compare with me and see if you get the same thing as me. All right, so you should get the following answers. If you did not, please make a note to yourself to ask me these questions tomorrow, okay? All right, next thing we're going to do is the same thing. We're going to find the sine and the cosine and the tangent of certain angles. But right now, if you look at your triangle, you only know 2 out of the 3 sides, which means we have to figure out the 3rd side. Easy, we can find it easily without any issues at all. So to find this angle right here, all we have to do, the side, is use Pythagorean theorem. This is the c value, okay? So I'm going to find out what 7 squared plus 24 squared equals x squared is, okay? Go ahead and solve this. Again, press pause, come back to me, compare your work with mine, see if you get the same answer as me. So if you go through and you do all of your work, you should end up getting x equals 25. So I'm going to get rid of this c right here, and I'm going to make it a 25. All right. So now I can find these answers, but this time it says in decimal form, not in ratio form. And that's easy. It shouldn't be a problem at all. It's all, for this first column right here, it's all based on angle B. And angle B is this angle right here. So what is the opposite, since sine is opposite over hypotenuse, what is the opposite of angle B? Well, it's the side that's across from it, which is 24. And then the hypotenuse is 25. So this would be 24 over 25, but you need to type that into your calculator and figure out what that is as a decimal. So just divide 24 by 25 and then round to the nearest thousandth. You should end up getting, your calculator will tell you the answer is 0.96. But since it's to the nearest thousandth, we'll add the 0 on. Okay? Now cosine of B, remember cosine is adjacent over hypotenuse. Okay, so the adjacent side is 7, so I would have 7 over 25. Put that into your calculator, and you should end up getting 0.280. Okay, and lastly, tangent of B is going to be 24 over 27 because tangent is opposite over adjacent. So when you type 24 divided by 7 into your calculator and you round to the nearest thousandth, you should get 3.429. Okay, and then I want you to do the same thing for sine of C, cosine of C, tangent of C. Press pause, come back to me, see how you did, and if you are having issues with this, write yourself a note again to ask me tomorrow in class. These are the answers that you should get for the second column. All right, lastly, find the following rounded to the nearest hundredth. You literally just have to type it into your calculator. So you're going to type in SIN, open up your parentheses, type in 14, close them, press enter, and you should end up getting 0.24 rounded to the nearest hundredth. Okay, go ahead and try the remaining values. And when you're done, compare with me again. Don't forget to press pause, and then we'll be done with this topic. Remember, write yourself a note if you did not get the same answers as me and you need some help.